Yes, what I will do is in next 20 minutes, I will try to explain what is federated machine learning, challenges, solution, and also what we have done in terms of the research area and also in terms of the solution. But before going to the federated machine learning area, let's start with a bit of a basic kind of more classical machine learning setups that we have, I guess most of you are familiar with. So what we have seen over the years is that there are different devices or users that generates the data. And if we want to train a model, what we need to have is some kind of computational infrastructure. Most of the time, it's the cloud environment that we have. We pull all the data to the cloud environment, and then the training starts. And that's how we train our models, which is perfectly fine, and it serves the purpose for quite some time. But things has changed. The whole idea of pulling down the data on a single location for running the training processes is starting to become more challenging. And why it becomes a bit more challenging is because there are many reasons, barriers. First of all, if the data is private, it's difficult to just collect it on a single place. Second, for example, hospitals, banks, where there are more regulations involved, GDPR requirements, you are not really allowed to pull the data on a single location. And the third case is when actually it is not possible because of the size of the data to pull everything to a single place. So all these cases are something that actually hinders us to do the classical way of doing the machine learning process. But while we have this all kind of challenges, it also creates an opportunity for us to build new systems that are more privacy preserving and security aligned when it comes to the machine learning training process and model serving. And this is not something that only we have seen in research. The trend providers, they have also highlighted these kind of trends. And it's not like I'm talking about like 10, 15 years ahead. It's just like doorstep. And these are the kind of challenges and environment that we are in. It's not really possible to just do a simple classical way of machine learning in many cases. So what's the solution? One of the way forward is federated machine learning. What it provides is basically, it's a privacy preserving mechanism to train models. What does that mean and how it works? The idea here is that when it comes to the federated machine learning, there are mainly two actors involved in that, and it's mostly the classical way of doing the federated machine learning. We have this central guy, we call it aggregator or alliance admin, and then we have the clients that are that have their private data, and the promise here is that the data always stays in the client's premises. It will never leave, and client have the complete autonomy over the data. And how this whole process works when it comes to the federated machine learning, this central guy generates a seed model that can be anything like a neural network in many cases. And it tells the client that, okay, I'm sending you a seed model, start the training process, but don't run the complete process. Just run a couple of epochs. And once you have completed these couple of epochs, send me the model back, the local model. All the clients sends the local model to the alliance admin. Alliance admin do the aggregation, and the aggregation can be based on the Fed average, mean, median, geometric mean, weighted average, anything. And then this whole process iteratively continue. In the next round, what happens is that the model do the aggregation and send that aggregated new model to the clients, and the same process get repeated. And after number of rounds, you have a global model that represents the data that is on each client side, with the promise that the data never leaves the client's premises. Clients have always the full control over the data. So with that kind of very simplistic approach, one can really build the models without requiring the data to be pulled to a central place. Okay, yeah, that's nice. And based on that, what key benefit one can have? So in this plot, what you can see is that on the x-axis, we have number of members in the alliance, and y-axis is basically the score for this classifier. When we divide our data to two sets based on two clients, we can see that the local models and the global model, or the federated model or the local models, they are all very close to each other. But when you start increasing the number of members in the alliance, means the data on each client side started to become separate. And each client can have only view to a small data set. Clients cannot perform well on their individual local model, but together they have the possibility to build a system or a model that is well representative. And that is basically the key benefit of this whole mechanism. But I think that looks too good. There should be some problem here, or some challenges related to federated machine learning as well. So what I have shown you so far is a very classical way of running the federated machine learning. You have one aggregator, you have clients, they run the process. In the end, you have a global model that is very well represented. Okay, but when it comes to the challenges, there are number of areas where things need to be improved. And as you know that what I have shown you, it's a distributed system. In the end of the day, it requires quite a lot of like how the clients and aggregators communicate, what kind of network performance and all these things, how that works. And also, when it comes to the distributed system, you need to be careful about security and the governance. And just to, I will not go into the details of security and governance kind of area, but just to show you some aspects of how challenging things could be when it comes to the large-scale studies. So when it comes to the cross-silo kind of environment, what is cross-silo? Cross-silo means like when you have less number of clients, but each client has quite a lot of data. And when you have significant amount of data on each client side, the model started to become more complicated. And today we have seen like number of parameters in these text models and all these things where the model started to get very complicated. In that case, how easy it is to maintain this communication, because it's not a one-time communication. You need to run the whole process in an iterative fashion. So how you can maintain this stable environment in this classical settings? The second is cross-device environment. What is cross-device? Cross-device environment is when you have lots of devices in the wild and you want to build a model based on that. In that case, the challenge is not like the model will get very complicated or big. The challenge is how you maintain the connection from millions of devices in the system. So based on these kind of challenges, the basic architecture have some limitations. And if you want to run like a large-scale studies in real geographically distributed environment, it is not that easy to just simply scale to the kind of level that you want to go. What we have done in my research group and also at together with the company side is that we started to look at different architectures of how federated machine learning can go up to the scale that can handle millions of devices in cross-device kind of environment, and also in case of cross-silo environment. And here you can find quite a lot of details, but I just would like to show you the architecture and one or two interesting results that we have published. So the architecture that we have proposed in that article is based on this hierarchical approach where we have 3 tiers. We have the client environment that that's the lowest tier in the network. And on the second tier, we have divided the aggregator into 2 layers, combiners and reducer. The combiner's role is that it just takes care of the connected clients and also do the partial aggregation based on the number of clients connected to the combiner. And since this layer is stateless, if one combiner just die, clients automatically find out the other combiner in the network. And then the final model or the final aggregation done here at the reducer level, and that is based on the incoming partial models from the combiner side. So with this kind of hierarchical approach that is highly influenced by the map-reduce kind of architecture in programming paradigm, we have managed to design a system that can handle both cross-device and cross-silo environment. And then on the top, yes, sure, if you want to provide reliable environment for large-scale studies, you need to provide extra services as well. So that's not like a very fancy one, but it really serves the purpose of like how you design large-scale environments for the studies. What we have managed to achieve with that kind of architecture is on this side, you can see the geographically distributed nodes that we have. And on the right side, what we have achieved is like how far you can go in terms of cross-silo environment. We have used this 1 GB TensorFlow model for the training purpose. Here you can see that with one combiner, 6 clients, it is possible to run the setup. But then if you have 2 combiners, you can easily scale the whole environment to the 12 clients with that kind of big model. And with 4 combiners, you can go all the way to 40 clients, communicating iteratively over the network and train the model. And that's basically the kind of results that we have for the cross-silo environment. When it comes to the cross-device environment, where the number of devices are quite high and the individual data on each client side is low, then it's basically what you can see is that we have tried to show like what are the computational requirements are there in terms of providing the computational resources for combiners and reducer. And here you can see that we see that, okay, with one small combiner that is high CPU means what we have seen here, it goes all the way to 37% overall training usage. And then when we add one more combiner, it just drops to 14%. So it is it's a really horizontally scalable kind of environment that you can experience in that. And here, together with all the, you can say, information that is required to run a large-scale distributed environment, you need to know like where your framework is spending time. In terms of training, here you can see that the most of the time spent in this whole process is based on the training. But then you have this upload, download, all these things that are required to be known to the Alliance admin is also available. So we have developed an open source platform called FedN. Based on that, it's available, one can use that, and it has all these functionalities. Together with that, we have a commercial platform called Scale-Out Studio with enhanced features. That's more for the commercial purposes. So based on this whole environment, we are also part of a couple of EU projects and commercial commitments where we are using our platform to provide federated machine learning environment. The first use case that I would like to highlight is from the air traffic management system, where there are companies, there are airlines, they have their own data set, but it is not possible for them to share the data. And also, if you want to run the whole setup where you want to either improve the takeoff time or improve the route calculation, you need to have information from all different channels. You need to have information from this airport side, airlines, and weathers and whatnot. And federated machine learning is the kind of solution that serves the purpose in that case. The second use case that we have is another running project right now. And here we are looking at the brain tumor segmentation environment. And the idea here is that the hospitals that are not allowed to share the data, but as you know that each individual hospital has quite a useful data set, and if there is a possibility that you can train a model that represents data from different hospital sites, it can be very useful. So based on, in this project, we are part of this big consortium where we have the Swedish hospitals. And yeah, that's how federated machine learning is empowering all these challenging use cases that otherwise have quite a lot of limitations. Yeah. As I said, we have this open source platform. If you want to try, it's available. And also this studio that has more features, but that's more like a commercial product from us. So that's all. Thank you very much for listening.
Thank you so much. Do we have questions from the... Yes, we do.
Thank you. Great presentation. I have two questions, and one is, there was one graph where you were showing the number of, not devices, but the total collectors that you were having, and how much was taking the training time.
Yeah.
Does it scales linearly or not?
It really depends on what kind of model you are using and what kind of devices you have on the in the environment. So, for example, if you have a model that is big, but on the client side, one client has quite a lot of resources, the second has a bit limited resources. These kind of heterogeneous environment affects overall in the training time. But we have designed a mechanism where the Alliance admin can set a timeline. That okay, anyone who can respond within that time will be part of this round. Otherwise, in the next round, the client will participate.
And the second question is that when you were aggregating the performance, you were saying about this aggregate statistics, this federated mean, and so on and so on. Can you combine this with differential privacy, or?
In principle, yes, but it really depends on like what kind of model you are using, and if the model have the kind of adapter for the federated machine learning, but for the differential privacy, sorry. But otherwise, if you see federated machine learning, it's nothing like a very, you can say, an edge kind of case. It's just very simple. You have devices, they share the gradients. You do the updates on the based on the model that you have or the aggregator that you have. It can be ensemble, federated average, or anything, and yeah, that's all.
Next question. Oh.
Hi. In a situation where you have a lot of clients and they all gathering the data to the central model, I assume that some of the clients won't have the same interesting data as other clients might have. Do you have mechanisms to give more importance to these clients rather than these clients, or is it just embedded in the model?
Right now, no. But that is one of the very interesting research area that I'm working in my research group, because it really, one can do many things, but the problem is that the more closer I go towards the client's data, I breach the privacy. And the whole idea of this platform is that the promise is that we will never gonna touch or do anything on the client side. Whatever comes from the client side is, in the end of the day, a local model, right? That is what you do the aggregation. Federated machine learning, it's quite a lot of research work that has been done in terms of non-IID cases, unbalanced data sets, and also these kind of challenging use cases. But yeah, it's what we have done so far is more like horizontal federated machine learning cases.
Thank you. I saw, yes, a hand raised there.
Hi. I mean, the question is kind of similar. For testing, I'm guessing that you are getting the output from each of the clients, like how the aggregated model is working for them. But if there was some kind of biased data, or how do you control the quality of the data on those cases? Because on a normal model, you can actually, check through layers or check through that. I don't know, it's a set of blurry images, or is a set that's affecting the model?
Yeah, that's a very important aspect. But right now, the situation is that if we go more towards, as I said, close to the client's data, then then we started to expose the kind of settings that client has, and that is out of the scope of this. However, what one can do is that each client, so we don't do any validation or testing at the global side. What we do is that once you have the global model ready, you send it to the next round, and the client can have two roles in our framework. One is the trainer, and second is the validator. And in that kind of environment, if the client has a validator role as well, they can have their own separate validation or test data set. They can just tell us like, okay, this is the kind of accuracy I can see on this model. So that is what you can, in the end of the day, showcase to all the alliance members that, okay, we have this nice global model. Client number one can see that much of accuracy, and the others can have the other. But when it comes to the actual raw data, the promise is that there will be no direct communication with the data.
Any more questions? Yes, down there. Thank you, Darina.
Hi, thanks for a great presentation. I was just wondering, I'm not familiar with federated learning, but you mentioned that the methods for combining the models, you could do a simple mean or median or something. How well does that work? I mean, if you train or fine-tune models on different places, yeah, can you comment on how well it actually works, just simply combine them?
Yeah. So if you take the mean of a fully trained model, it will not gonna work. But how the federated machine learning works, like in each round, you ask the clients to just slightly train the local model and send that. And then you do the aggregation. And then that process runs multiple times. So with this slight modifications coming from the client side makes it available, makes it possible to have a model that can well represent the different sites. But obviously, if you have a fully trained model, then it will not work. And by the way, I can also mention that federated machine learning is something that is highly used in this Google keyboard environment, and also Siri is using that. Facebook is using these kind of things, but their solutions, they have published some material, but there is more going on in the research, both in terms of privacy, security. Yeah. And one last thing that maybe I can mention, we run workshops every month. If you would like to join and really start a client on your site and join the alliance, please, here is a barcode available. You can scan that and join us. Yep.
Salman, thank you so much for your talk.
Yeah, thank you very much.